Shape keys are used when we want to create animations showing smooth transitions of an object from one shape to another. Specifically, they are often used to create different facial expressions. To explain the basic principles behind shape keys, we'll start with a cylinder. Now, with the cylinder selected, we'll move to the Properties Editor's Object Data page. Here we'll find a shape keys list. Initially, the list is empty, but if we press the plus button, an entry named Basis will appear in the list. This represents the original starting shape of our mesh. Now, if we have thought ahead to the different looks we want to mold the object into, we can add a new shape key entry for each look. In this example, we are going to have 3 different looks, so we'll press the plus button 3 times. The new list entries are given default names, but it would be better if we change these to reflect on the new shapes we are going to create. In this case, it will be narrow top, wide base, and arm. After selecting narrow top, we'll move into edit mode and reshape our cylinder to the shape we want to associate with this key. Next, we'll move on to wide base. Notice that the cylinder returns to its original shape when we do this. After defining the look we want for this shape key, we'll move on to the final key, arm. This time, we'll move out one of the side faces. Now, if we click on any of the 4 named keys, the cylinder will jump to the shape associated with that entry. When we return to object mode, the selected mesh shows all 3 of the changes we made. Notice that there are 2 symbols to the right of each key name. The is a checkbox termed Mute. If we uncheck this box, the associated shape key features are no longer shown in the displayed object. The next symbol is the Lock key. If we click here, we see a closed lock, meaning that we cannot edit that shape further. This is simply a safety feature to stop us changing a shape by accident and is commonly used on many properties in Blender. Below the shape key list is a checkbox labeled Add Rest Position. Selecting this adds information on the original shape to a data block. The purpose of this is beyond the scope of these videos. We'll skip ahead for the moment to the field labeled Value. Normally, this ranges from 0 to 1. The value here determines to what extent the currently selected shape key affects the overall shape appearing in the 3D viewport. A value of 1 shows the full extent of the shape key change, while a value of 0 shows none of the change. Actually, the value is repeated in the shape key list itself, and can also be adjusted there as well. Moving on to Range Min and Max. As we have said, value normally has a range from a minimum of 0 to a maximum of 1, but we can extend these 2 values by changing min and max. Blender automatically extrapolates what shape the extended range would create. For example, with arm selected, and min changed to -1 and max to 3, adjusting value creates the range of effects we see here. The next field is Vertex Group. If we have previously created a named vertex group and select it here, then any changes we make in edit mode when defining a shape key will only affect the vertices in that named group. To demonstrate, we'll name this set of vertices Top. Now we'll return to object mode, add a new shape key leaving it with the default name of key 4, and select Top in the vertex group field. Now in edit mode, we'll extend another face on the side of the cylinder. Note that this moves vertices at both the top and bottom of the cylinder. But when we return to object mode and activate our new shape key, only the vertices from the selected vertex group are affected. Next we have Relative To. When we create a new shape key, the default is that our initial shape is that defined in Basis. But if we enter a different value in this field, then the new shape key is influenced by the key listed in this field. For example, let's use a cube with 4 loop cuts, both horizontally and vertically. We'll set up 3 shape keys using the default names basis, key 1, and key 2. To start with, we'll have key 1 and key 2 relative to basis, and things work as we would expect. Now let's change key 2 to be relative to key 1. Now, as we reduce key 2's value, we see the shape associated with key 1 appear. Adjusting the key 1 directly still creates the original effect. But if we reduce the value for key 1 and then adjust key 2, we get the effect we see here. Above and to the right of value are 3 selection buttons. The star-shaped symbol is the solo button, which shows the effect created by the currently selected shape key only. The shape produced assumes a value setting of 1, irrespective of its actual value setting. The next button is the Edit Mode button. With this selected, Edit Mode shows the shape of the mesh using the current value of every active shape key, rather than only the currently selected key. The third button is the Clear button, which normally resets all of the shape key values to 0. However, if any key has a min value greater than 0, that key is reset to the min value. Using 2 UV spheres, we'll look at the options in the menu activated by this down button. We start with the sphere on the right, being assigned shape keys, key 1, and key 2. New Combined creates a new key based on all of the existing active shape keys. The new key combines the effect of all other keys using the current state of the keys it has copied as its minimum. That is when value is set to 0, and double that when value is set to 1. Duplicate makes an exact copy of the currently selected shape key. The new key adds to the effect currently created by the original key. Copy from Objects copies a shape key from some other selected object to the active object. The 2 objects should have the same starting geometry. With key 1 in the right sphere selected, we'll select first the right sphere, and then, holding down the Shift key, the left sphere. Since it was selected last, the left sphere is now the active object. Now, when we choose Copy from Objects, the currently selected shape key of the right sphere is copied to the left sphere. Note that the Solo button is activated to show the effect of the new shape key. The default value of the new key is 0, so when we switch off Solo, we need to increase key 1's value to see the effect. New from Object copies all the shape keys from the source object to the target object. Notice that all the source keys, other than basis, are copied into a single entry named after the source object. New from Object Flipped is a variation on the previous option, but this time with the copied keys mirrored on the x-axis. However, to get this operation to work, we need to rename the sphere so that the names end with .l and .r. Update from Object. When we've used New from Object, and then one of the shape keys is edited in the source object, we can add that change to the target object using Update from Object. Update from Object Flipped is used to update the keys in the target object when we've previously used New from Object Flipped. Flip changes the direction of the currently selected key by adjusting its x-coordinate, but this only works when the object's mesh is perfectly symmetrical. This gives an easy way of creating both left and right shape keys. Flip, topology, is similar to flip, but apparently also works when a mesh is not perfectly symmetrical. And although it seems to work sometimes, there are other situations where it gives very strange results. Lock All locks all the keys, while Unlock All unlocks all the keys. Make Basis makes the currently selected key the new basis key, moving it to the top of the list. The previous basis key should be deleted, and, to prevent confusion, the new basis key renamed. Any other existing keys will create exactly the same geometry they did before. This means that geometry changes made by updating the basis key disappear as we increase value for those other existing keys. However, if we switch off all the existing keys, any new keys we add after changing basis will start from that new geometry. Yes, it's a bit complicated. Apply All uses the current settings of all the shape keys to make a permanent change to the mesh, and at the same time deletes all the shape keys. Delete All deletes all the shape keys without affecting the original shape of the mesh. Let's jump back to the Relative checkbox. This is selected by default, giving the results we've already seen, with the final shape being a combination of the shape keys adjusted by their value settings. If we uncheck Relative, the shape keys we create are known as absolute shape keys rather than relative shape keys, and the fields below change to interpolation and evaluation time. Jumping to evaluation time, this acts rather like a timeline. As we drag from left to right, we transition through an animation showing the change resulting from the shape keys as they are each applied, then removed in turn. As one shape key effect advances, the previous one reduces. Interpolation has a drop-down list. Each option here has a fairly subtle effect on how the mesh migrates from one shape to the next. Notice too that the number shown beside each key increments in steps of 10. This gives us an indication of the time at which each shape key will reach its maximum extent before starting to reduce and be replaced by the shape associated with the next key. We can confirm this by watching how the setting in evaluation time matches with these values. These values do not represent seconds or frames in the animation, even though Blender names the field frame. When using absolute keys, we can add new keys at any point in the list. All we need to do is set evaluation time to some value corresponding to where we want the new key to appear before clicking on the plus key. The new shape key is assigned the time shown in evaluation time. However, this does mean that each effect created by the keys are not assigned equal amounts of time. If we want to fix that, we can press the Retime button that appears in place of the Clear button used with relative shape keys. This resets all of the frame values to increment in steps of 10. We can also reorder the existing keys simply by dragging them within the list. Blender will automatically adjust the frame field values to correspond to the new key listing. As we mentioned at the start of this video, shape keys are frequently used to create facial animations. Using this approach saves us from having to use bones to do the job. So let's see how we can achieve a smile on Suzanne's face using shape keys. First, we'll start with a basic Suzanne mesh and use the subdivision surface modifier to achieve a more realistic look. Now we'll add two shape keys, basis and mouth_R. We'll edit this one to turn up the corner of the mouth. Next, we'll make a copy of that shape key, rename it, and flip it. Now all we have to do is adjust the two mouth keys to achieve the effect we want. Although we haven't yet discussed animation details in any of the previous videos, we did mention back in the first video that a main component of animation is the keyframe. So let's see how to set up keyframes and give Suzanne an animated smile. In the timeline, we'll move the pointer to frame 1. Next, we'll select mouth_R, setting its value to 0, and press the Animate Property button to the right of the value field. And then we'll repeat the process for mouth_L. This marks the current value of the mouth keys as keyframe details in frame 1 of the timeline. Now, we'll move the timeline pointer to frame 24 and set mouth_L to 1 and press the Animate button. After repeating this process for mouth_R, we have our second keyframe. All we need to do now is press the play button at the top of the timeline, and we have our animation.